Okay, some other properties I want to use are, and we've kind of used these a little bit already when we were simplifying roots. If you want to take the cube root of something, you can raise it to the 1/3 power. Or if you want to take the fourth root of something, you can raise that number to the 1/4 power. So square root of 3 could be rewritten as 3 to the 1/2, for example. You can also do it that way in your calculator. You can type in 3 to the 1/2 in your calculator, and if you do it correctly, you'll get the same number as if you took square root of 3. You can also, if you raise something to a fractional power, up until now we've never really known what that meant, but if I want to raise 4 to the 3/5 power, this second property, which it's a little hard to see, basically says that the number on in the denominator becomes the root you're going to. So it's fifth root. And the number on top is the power that you raise to. So 4 to the 3rd. And actually, this one can be simplified a little bit more, I think, because 4 to the 3rd is actually 64. And 64 could be rewritten as 32 times 2. I didn't really notice that right away. And you're saying, well, who cares about 32? Well, 32 happens to be 2 to the 5th. But you might not have noticed that. It's a perfect 5th power. It's a power of 2 to the 5th. It's the power 2 to the 5th. So I can rewrite it as a 2 on the outside with the 2 left on the inside. But you might not have noticed that. I understand that. That was just kind of lucky accident that happened. But the important thing is, when you raise to a fractional power, the denominator is the root, the top is the power. Okay? So let's do a couple examples of this. Let's do 4 to the 1/2, which is square root of 4, or 2. And if you want to skip this middle step, if you're able to do that, you are more than free to do so. Or negative 27 to the 2/3 power. Well, you could square this first and then do cube root. I think it's easier because you're dealing with smaller numbers if you do the cube root first and then square. And remember, the order you do it in does not matter. So cube root of negative 27 is negative 3. And then I want to square that, and I get positive 9. Or our good friend 32 to the negative 2/5. Well, first thing I'm going to do is I'm going to flip to get rid of the negative. So I have 32 in the denominator to the 2/5 now. So I have 1 over 32 to the 2/5. And then I can do 5th root of 32 and square that. So I rewrote my fraction as a root. I wrote it in radical form, I guess you could say. 5th root of 32 we already know is 2. And 2 squared gives me 4. So I have 1/4. And let's do a couple more. Let's do 2x to the 1/3 over y to the 2/3. What can we do with this? Well, and let's raise this to the negative 1/3. If we use rules for exponents, I think we can simplify this quite a bit, actually. So I can bring this. Well, actually, the first thing I would probably do, if I make that positive, a shortcut for dealing with fractions like this, if you make the negative on the outside of everything positive, you can flip your fraction right away. Just get rid of that negative outside. Getting rid of this negative has the effect of flipping everything. Okay? Then you take this 3 and you bring it next to all 3 things. I've got a number 2, so I have 2 to the 3rd. I've got x to the 1/3. I'm going to raise that to the 3rd. And I've got y to the 2/3 that's going to get raised to a 3rd. What is 2 to the 3rd? Well, 2 to the 3rd is 8. X to the 1/3 raised to the 3rd. When you multiply, you add exponents, but when you raise to a power, you multiply exponents. 1/3 times 3 is 1, so I just have x to the 1. When I raise to a power, I multiply exponents. Those two things cancel. I just get y squared. Okay? Now, I want to change what I'm doing here just a little bit. Instead of doing this problem that I was going to do for you, I want to do something else instead. It's another problem like what you will see in Pre-Calculus B. I want to simplify this. Now, the way that I'm going to simplify this is I want to try to write everything as exponents. So instead of cube root, I'll write it as 1/3 power. Instead of square root of 2, I'll write that as 2 to the 1/2. Now, 8 is a little bit tricky. I really wish these two numbers were the same, because if I had the same base, I could combine things. But if you think about it, can't 8 be written as 2 to the 3rd? I think it can. And now we use rules for exponents. Well, I don't know why I'm rewriting it again. So I'm spacing out now. So the rules for the exponents say that when you multiply, you add the exponents. So 2 to the what? Well, I don't want to write 3 plus 1/2 as 3. I don't want to write it as 3/2 because if I do that, I still have to change it to an improper fraction because I'm going to be combining with the 1/3. So let's change 3 and think of it as 6/2. 6/2 plus 1/2, I get 7/2. And then when I raise the power to a power, I multiply exponents, so I get 7/5. And you could leave your answer, or 7/6, I should say, 7/6. And you could either leave your answer like this, 2 to the 7/6, or you could convert it back to radical form with square root. So you could have 6th root of 2 to the 7th, or you could write 6th root of 2 raised to the 7th. It's up to you. I actually think I like this one a little better, but it's totally your choice. So here's a little preview of Pre-Calculus B for you. Don't be scared. I think you're going to be really excited when you get there.